Hello there, and welcome back for another video. We are ready to start composites. So in the geometry text, if you go to your 5th tab, we're almost finished with this course, we will look at some composite shapes. And before we get started, I just want to tell you what the word composite means in this text or in this context. We're looking at shapes that are made of two or more shapes. So basically, we're looking at shapes that have squares and circles stuck together, rectangles and triangles, any combination of polygons and circles stuck together. So composite means stuck together in a very simplified form. And in the first few problems, we're going to look at two-dimensional composites or flat surfaces, flat shapes. And then as we go on over, you'll see that the shapes become three-dimensional. So we'll be looking at a lot of different formulas that you already know, but this is a good review of those formulas. So for the two-dimensional composites, I want to find both the perimeter and the area. And that's why you see two of the same problem. So I'm going to zoom in just a little bit, and I promise I won't zoom in and out on you because I realized how very difficult that is to watch. And I'll only zoom if it's necessary. So to do a two-dimensional composite area, I want to start with area on this one because that's the easier of the two formulas for this shape. What I want you to think about is an imaginary line, and I'm going to call this the parsing line. I'm not sure if that's a proper term or not, but it's what my teachers called it, and it helped me to remember it as something that I needed to know. So a parsing line is an imaginary line. It's something that you and I are going to draw in. It does not become part of the problem. It's just to help us visualize the problem a little bit easier. So in this problem, I'm going to draw my parsing line right here. And you can do that with me if you like. Now, I want to show you that I could have drawn it this way. Okay, that would have been just fine. We could even draw more than one if we needed to. But they're just lines that we're using to section off the shape. So let me put this one back in and we'll look at what we have. Once you draw the parsing line, you can see that you have two different shapes here. This yellow one, and I probably will color all of these because I think that helps you visualize a little bit. Even though this is not to scale, this one is a square. And I found these problems on a free worksheet website. So I did not draw these myself. I would suspect that none of them are to scale. But this is a square. And then in this side of the problem, let me see if I can color a little faster. We have a rectangle. And all the parsing line does is divide those two into sub-shapes or smaller sections of the bigger shape. And this is a good illustration of what composite means. As soon as I put the two pieces together, I have made a composite. Another use for that word is if you're taking the HiSET exam, you will have 5 subtests: reading, writing, math, science, and social studies, and then you'll get a composite score, an overall score. Okay, so we want to find the area of this whole composite shape. So this piece is a rectangle. Let me write it in here. And this piece is a square. And we can use the same formula for both of those. They're both four-sided polygons. So the area of the rectangle is length times width. And we'll use the same formula for the square. You could also use side to the second power for the square. But for the rectangle, we want to put in the parentheses for our variables. And the rectangle is 15 long and 14 wide. You can reverse those and you'll still get the correct answer because you're multiplying. And I'm not going to risk doing that in my head. It's a good thing because I would have been off by about 10. So 210 square yards for the blue section. And then for the yellow, let's do the problem again, the formula again. And this is a square, so both sides are equal. And that one I can do. In my head, it's 144 square yards. And while this is in my head, let me go ahead and tell you something here. You want to always make sure that you're dealing with like units. So notice that these are all yards. If they were not all yards, you would have to fix that before proceeding. So if they gave you one of them in feet, you would have to deal with that before you could do this problem, or at some point you would have to deal with that. Okay, remember though, this is a composite. We're not just interested in one or the other shapes. We're interested in both of them together. And I don't know what's going on here. Okay. So I need to take the two pieces that we have and put those together. So I'm going to add those two pieces together. 210 plus 144 gives me a total area of 354 square yards. So the composite area of this shape is this number right there. And we're talking about the number of little squares it would take to cover that surface. Maybe that's my living room and dining room, and I want to put carpet down there. So how many square yards of carpet would it take to do that? It's a very big area that would need to be covered. Okay, let's look at the next problem, which is related to this composite, and it is a perimeter problem that we need to find. This one's a little bit more of a challenge because we're missing some dimensions. So the first thing I would ask you to do is to count your sides. Make sure that you have all of your sides accounted for. So here's 1, 2, 3, 4, 5, and then back up to that corner is 6 sides. So this is a hexagon. There are 6 sides that we need to account for. And we only know 4 of them. Let me highlight those that we know. We have 1, 2, 3, and 4. So 2 of these 6 sides are unknown to us at the moment. We don't know this little bitty one, and we don't know this biggest one down here at the bottom. Okay, so let's take a look at how we can find those, and this requires a little bit of logic. I know that this distance, and if you want to put a parsing line in there, you can. That's no problem at all. But I know that this distance is 14 yards, and this one is 12. And I know that by looking up here at the parallel sides. So if you add the 14 and the 12 to get that whole bottom row, you're going to get 26 yards for the bottom. So we found that largest side. Now we need to focus on this little fella, that little yellow section right in there. So to do this one, I'm going to have to use some subtraction. Now I know that from here to here is 15, and from here to here is 12. So if I say 15 minus 12, let me just do that right in here, that leaves me with 3 yards for that little piece right there. Okay, so now I have all 6 sides, and we can find perimeter. And I'm going to have to give myself a little bit of space. I've used up all my room. Let me do it this way. I write so big, and it's hard to get all of this in there. So all 6 sides. Remember, to get a perimeter, you just add up the sides. So I'm going to start with the 15. It doesn't matter where you start, but I'm going to say 15 plus the top, 14, plus that little piece, 3, plus 12, plus 12, plus that big bottom one all together is 26. 1, 2, 3, 4, 5, 6 sides. And when we type this into the calculator, again, don't risk missing your problem because you didn't put it in the calculator. Also, don't miss it because you didn't write it down. It's very easy to miss one of these sides. And let me highlight for you where these are coming from. Okay, I did 15 plus 14 plus 3 plus 12 plus 12 plus 26. And let me check that one more time. I am very bad about missing numbers or reversing numbers, but I'm getting this twice, so I will assume that 82 yards is the perimeter of this shape. So composite shapes are not easy. They require that you pay very close attention. I'm going to stop the video before I start the next problem, and we will do another composite.